So welcome. I'm going to be jumping around for the next hour to kind of keep you away, power through that food coma. Sorry? I'm sorry?
Is that a record?
Am I what? Sorry?
You're supposed to record the slide.
I am recording. Thank you. Yes, so we'll just have to cut out those first couple of minutes. You can maybe start now, so you don't have to see my introduction again. Anyway, so I'll talk to you a little bit about Scala 2.10 in general, a bit of Scala 2.11, but I'm going to be focusing on what supposedly is my favorite feature in Scala 2.10. So I'm the Scala tech lead at TypeSafe. In a former life, I was a postdoc at EPFL, working on the theory of Scala. And now I'm firmly on the dark side. So first of all, thank you to all contributors. Got a lot of those and getting more every day, so you know who you are. I'm not going to go through the numbers, but we're very happy to be in touch and get a lot of bug reports. It's always fun. So as I said, I was going to keep you awake through your food coma, so I'm going to start with some to stir some controversy. And I'm going to say that Scala is simple, and I'm kind of not really going to prove that. I'm just going to illustrate it, I guess. Rich Hickey did a really nice talk about how simple and easy aren't the same thing. So no one said it was going to be easy, certainly not me. So I am serious about this, and be warned that it doesn't mean it's going to be easy. And one way that I claim Scala is simple is because it's a unifier. So by unifying more concepts, you have fewer things to learn. You just kind of have to learn the core set and then how they relate to each other, or how they simplify to each other. As a classic example, you have functions and objects that are unified, as you all know by now. And there's a couple more that I'll point out during the talk. So it doesn't just unify language features, it also unifies how you use it through the REPL that Paul poured a lot of manpower in and get it to the point where it is now, where all my experimentation and a lot of bug fixing in the Scala compiler happens in the REPL. And you can do large-scale development, and I don't think that requires proof at this point. So like I said, there's a simple core, and it's essentially objects and methods. Because that's what we have on the Java on the VM, and most of these things, of these other features that, when you first see them, might seem like a bunch of complexity and lots of stuff you may not want or need, and that may very well be true. But most of them can be understood in terms of the simple core, and they all follow the same kind of strategy of how they are desugared into something that can be expressed in this core. And so in this talk, I'll talk a bit about how that works for string interpolation and for pattern matching. For comprehension is another example where really that's just a bunch of flat map, and with filter calls with the likes of a little bit of nice syntax on top. Pattern matching, you can actually put the pattern matcher in virtualized mode, so to speak, where it's a lot like for comprehension, actually. String interpolation, I'll explain in detail. Context bounds, they're just syntactic sugar for implicit arguments. Oh yeah, one thing I forgot to say in my introduction is please interrupt. I don't really know what you know and what you don't know, or what you would like to know. So at any point in time, just call me out on something if there's something you disagree with or you would like to know more about. I'll try my best to make it as interactive as possible. You disagree? Well, let me make an example out of you. What do you disagree with, pray tell? Everything. Everything. Oh, well, you disagree. OK, so he disagrees, so don't ask him any questions or ask him for comments. I'm sorry? Oh, no, that's just kind of my meta notation for saying when you write this in Scala, really what it means is you make a new, I had to fit it on one line because I didn't want to spend more than that on it. But so whenever you see a function literal, there is no such thing, even though Java 8 might pretend there is no such thing on the bare metal. There is just classes which are instantiating an anonymous version of here. It's actually new function 1, but that didn't. And so then there's your apply method. So function literals are just objects that have an apply method that take the same number of arguments as your thing. And my twiddle there is just to kind of say it. We kind of. Oh no. So sorry, your question was more advanced than that. Well, I'm sure you could somehow, but I wouldn't recommend it. Sure. Yeah, it's on my GitHub. So that's github.com/. Sure. Yeah. I can't guarantee you'll be able to read my handwriting any better than. So GitHub. And then you got to count your A's. Adriaan M. And then I ran out of space there. Just continue. No, I won't. It's talks. And then I believe you're going to have to write something like tree master Scala 210. Or you could just click your way to it. I'm sure once you get to Adriaan M/talks, you'll find it. I think I pushed before starting my talk, so if you want to run key down, you can follow on your laptop, but luckily the projector is working, so. Yeah, so OK, I guess that covers that slide. Anything else? Great. So we're going to be doing some experimenting, which you might want to do on your own laptop, but I'm just going to do it here. I really hope everybody can read it, because I don't know much about CSS, and I don't know how to change the font size on this anymore. I wrote this talk a couple months ago. But so I hacked together a little thingy that will, I'll take a word or a phrase, or I disagree or something, and I'll print it. Just to prove you, I mean, like I promise I didn't make Paul say that, so I could just like rig the show. But yeah, Paul disagrees. Is there there, no one saw that one coming, so that's not scripted. So we're going to have a REPL at our disposal in these slides. Those are also on my GitHub. People have forked it since. I think Jason has a nicer version, and Andrew, I forget his last name, for Scala Puzzlers this year, Scala Days, also used it for a nice talk. So whenever you see one of those boxes appear, feel free to shout out code you'd like to see in that box to try something out. Not in this one, though, because I'm just going to quickly show you how it works. So we just have a WebSocket running thingy. I just Googled something that's actually, I believe, deprecated API by now. But it's just listening for messages, and it's sending it off to the interpreter, whatever my JavaScript thingy here sends from the web browser. And then the interpreter will split that string it got. This is extremely robust code, so please don't run this in production. But it'll call into the standard Scala interpreter and send that string off and send the result back, and you'll see it appear. I have some crazy patterns going on here that I'll talk about in a minute. Because, well, I was writing a talk about string interpolation, so I went nuts with string interpolation everywhere. So here are the links, by the way. This is the wrapper for the REPL to kind of get a WebSocket running on top of it. And this is where, well, actually, it should be called talk, because right now there's only one there. But there'll be more. So I'll talk a bit more about that. First, I guess, since I promised to talk a bit about Scala 210, I'll give you some of the highlights. So the last thing I did on the not dark side was rewrite the pattern matcher. That's kind of was going to be my summer fun project, and then it became my last year fun project, and I'm pretty pleased with the results. I'll talk a bit about string interpolation today. I won't talk about value classes because I wouldn't recommend using them for anything but basic stuff. Do you agree or disagree, Paul?
I'm sorry.
Using value classes for anything but basic stuff.
I agree.
I got Paul to agree to something.
Just like specialization.
Yeah, so specialization, value class, especially those combined, I wouldn't recommend it. Yeah. Yeah. So I mean, yeah, there are some cool things you can do with them, but I would be careful. Implicit classes, I think, are pretty great. They just kind of encapsulate a pattern that's very common with implicit enrichment, I believe, is the official party line on that now. We also introduced feature imports to let you take away stuff from your developers if you're not comfortable with them using stuff. I can definitely see a use for that with some developers. Not looking at you, Paul. I'm not bitter. So Futures and Promises, I think, was a great addition to 2.10 with cooperation from Twitter and the ECA team and EPFL guys. I added dependent method types, or at least cleaned up their implementation. So now you can create cakes from your methods if you're so inclined. And we got a great new ASM-based backend, which brought us 1.7 and 1.6 bytecode support, and it's also a bit faster. We're kind of continuing in that team. That's Miguel at Garcia at EPFL, who's doing a lot of good work there. The next-gen optimizer that's going to be experimental in 2.11 for now. So then I guess we have the unholy trifecta at the end here. Trade dynamic, I guess, is the least unholy of all. It's pretty fun to. I'll show you an example of how to use it. So who's written or used macro in the room? I'm just curious. Let's start with written. I'm glad to see that. All right. Who's used? Well, you probably wouldn't know because it just looked like methods, but OK, so good. All right. Sorry?
Fast track counts as macros.
Yeah. So then, yeah, a lot of you have used macros. But I think it's good that not too many people are writing macros for now because we're still working hard to figure out the API there, and it's bound to change, and it's going to keep changing in 2.11 until we get it right. We're not going to set anything in stone until we're semi-confident it's better than what we have now. And so 2.11 is going to have most of the features you have in Scala 2.10 for macros. I mean, for macro authors, that is. But it's going to be experimental, and it's going to be changing because we're still thinking about how to give a nice API into a compiler that really wasn't designed to expose its guts like that. So a quick word about the pattern matcher. If you've ever had an exponential space bytecode explosion, you'll be glad to hear that's fixed in 2.10. Overall, it fixed close to 100 bugs. We kind of just rewrote the whole damn thing and chucked out the old one in 2.11. And I'm very glad to say that we're getting external people helping out with its implementation, like getting a better CNF encoding. Yeah, we're working on improving it further in 2.11. I'll talk about that in a minute as well. But you can do some cool stuff like overwrite what it means to match. So you can make pattern matching backtracking or probabilistic or whatever you want. That's experimental, but it's kind of fun to experiment with if you like that kind of stuff. I'm sure everybody's used pattern matching here before, but since I have this REPL, I was going to just, show you. So if I just naively write something like a function that checks some option, and I'm sorry if is this readable? OK, I'm glad. And I hope you're just being polite because I said I can't change it anyway. But so we're looking for an available result that is magic. So obviously, there's a couple of ways in which this can crash. And the Scala compiler will tell you now, and it will give you examples. It'll say, well, if you pass this a none, you'll get a match error. Or if you pass a sum that doesn't have a magic string in it, it'll crash as well. So I won't go into too much detail. I mean, everybody knows how to fix that. Well, you just do this, right? Done. But anyway, so it'll tell you a lot about which cases you're missing as long as you're dealing with sealed hierarchies of traits. You can get a lot of nice error messages for there, and that will save you some match error agony at runtime. Any questions about that? I guess that's all pretty obvious. So as I said before, Scala is a unifier, and extractors and pattern matching are another example of that. We didn't just bolt pattern matching on top of an OO language, because it's fundamentally disruptive in a language where you care a lot about encapsulation. You don't want people just looking at your state. You want to be able to customize. You want to be able to evolve how you represent your state. And that's what extractors do. They give you a handle on how pattern matching actually goes to that state so that you can change it if you want to. So you start out with case classes. You get, the pattern match will go straight to your fields to extract those as subpatterns. later you decide, actually, I don't want a case class. I want to do some extra magic behind the scenes. Well, you just write an unapply method in the companion object for that class. And your matches will behave in the same way, except that they can do whatever logic you want behind the scenes. I'll give you an example of how that works in a second. But that kind of goes back to my statement earlier, is that really what it's all about is understanding how pattern matching and extractors, how they desugar into method calls. And I'll show you how that actually works. And then my claim is the complexity of pattern matching is reduced, because really what you need to do is understand the core of methods and objects, and I'm pretty sure you understand that already. How do I understand pattern matching in terms of that? Well, that's something you need to learn. But I'm sure all of you have. So right now, that requires option boxing. Abstraction always comes at a cost, right? But Paul is, as we speak, I mean, I'm disappointed you're looking at the screen instead of your screen, but we have a couple of ideas of how to avoid the option boxing overhead and applies and so on. And so that'll land into 11 pretty soon. So as I said, I was going to show you how extractors work exactly. And this goes back to, if you were reading really fast, an extractor I was using in one of the earlier slides. So let's say we want to match a string and get an integer out. So this is going to have an extractor that does the conversion from string to int, if possible. So just using the try that we got from Twitter is util toolchest and write and unapply like that. So really what this line is just saying, well, put your constructor in reverse and tell me if this is something you could have constructed, essentially. So this match, really what it does is it calls I to unapply, because I was the pattern here. And it will line up all the subpatterns it saw under this pattern here with the results from the unapply. So in this case, we only return one result, but you can return an option with a tuple in it, so you can return up to 22 results. There are no plans to increase that number. However, with Paul's changes, in principle, there wouldn't be a limit like that. Huh? Right. Right. So, but for now, unfortunately, as long as you're dealing with tuples, you can't have more than 22 subpatterns. So is this kind of just abundantly clear, or am I going too fast? It's hard to say with a mix of face like that, so I'll just be optimistic. I know it's just after lunch, I know.
But desugared match into match.
Well, yeah, OK. Fair point. We're kind of peeling off the onion with layer by layer. And so this you can desugar further. And I kind of assumed that this would be a standard pattern. But yeah, we can take it much further. So really what this does is not the greatest editor in the world. So we call this the scrutiny. And it says, now you see why I didn't type this. I don't really want anybody to know. There. So, well, actually, that's like subpattern 1. And then you say if subpattern 1. And I mean, there's this whole chaining of ifs, obviously, saying like if this check passes, then do that check, and so on. We were smarter about caching those things. And I mean, like, we don't do the same check twice most of the time. Well, it's an instance off check, right? So it'll be.
Yeah, but doesn't it like pre-fills one way or another? So you're looking for null at some point.
Right. Yeah, I mean, it has to check for. It actually has to do more. It has to check that 10 is a string and so on. And so I'm kind of giving you like, you can really, if you want to see, I can tell you the secret boss code for Scala C that will show you the desugaring of matches. It's not A, B, A, A, B, but there's some way of showing you what's happening behind the scenes. But essentially, it's just a nesting of ifs. I don't have this feature in the REPL here, unfortunately. I could go off the screen, and then I'm sure I'm going to go over time, so I don't want to do that. And what it really comes down to is saying something that is like that. It's kind of like that, roughly. So a pattern match kind of does a depth first reversal of your tree, of the data structure that you're decomposing, and every layer it peels off, it does either equality checks or instance off checks, or it invokes an unapply. And then it just goes in according to the rules of how you match a pattern. Like if it's constant, you do different things from when it's a type check. And I mean, for example, the argument type that I give here tells the pattern matcher that actually needs to check that what you're unapplying is actually a string. And you can also communicate whether your extractor is always expected to succeed by returning a sum instead of an option. So the pattern matcher will see that as something that can never fail if you return sum from your unapply. It'll do various things with unapplied seeks that I'll get to later, checking the length and so on. But the core thing is just it's a bunch of chained if then else's, where the else's throw match error in the end. So no idea how far in I am, but we're finally getting to the meat of my talk. 20 minutes. All right, doing good. So here's a couple of ways that you can now at least try to write generating a string with an embedded number. So the way to read this is it's a string literal that's interpreted under the S string interpolator, and it has one hole here that's going to splice in the n variable into that hole. So the n here is defined as an argument. I'll explain in much more detail exactly what those letters mean and so on. So here's an f, like the printf interpolator, that will splice in the same n, but it will do so under the %d formatter, and it will actually check that the n corresponds to the expected format here. So if I run this, I'm going to get an error because there is this broken bottles thingy here where I sneakily tried to pass in a double where an int was expected by the format specifier. Now, the compiler doesn't know anything about any of this. That's actually macro. So in a sense, the compiler does because it ships with the compiler. But it's not part of the string interpolation spec. It's just, the string interpolation desugaring kind of gives you this kind of checkability when you compose it with macros. And I won't go into much detail about macros because I don't want to get anybody too excited about them. But I will I'm happy to answer questions about them later. So really what string interpolation does is you drop all the holes that are demarcated by $, and you can actually put accolade, like curlies, around if you want a more complicated expression in there. So you can put arbitrary expressions in there. And then pack all those parts in a string context. So make an instance of string context. Call the interpolator, which is that name that is before the string, and it can be anything. S is the one that's standard, that comes with the standard library. And then pass the actual values of those holes as you specified them after the $, and possibly within those curlies, as arguments to that method. So for example, the first one actually desugars into create a string context. I've dropped the $, and since it was the empty prefix before the hole, I'm just going to pass in the empty string here. So essentially, every comma in your list of arguments corresponds to where I'm going to splice in something later. And then bottles of beer is the remainder of the string with the $, dropped. And then I'm going to call the S interpolator, which is just a method on string context. And I'm going to pass in the n, which comes from the $, from the first hole, and the only one that was missing in that string. So I'm guessing that idea is clear. So somewhere in the standard library, we have that S method that is defined directly on string context. There's nothing magical about it. We just do this dumb translation, and it just happens to work out because that's how those methods look. And the S interpolator will take any number of arguments, and it will just do the format magic for you as you would expect in an efficient way of constructing strings in Java. Any questions about this?
Is there a parallel there that you use the S formatter and the name method as well?
Yes, exactly. So the prefix you put before the string literal, that's the name we'll use for the method that we call in string context. So that's how you get to insert your own. It's not mandated what they are. We just say, well, the standard library has these by default, and that's just how it happens to work out when you write those. But you can write your own, yes, absolutely. And people have, for example, a quasi-quote library, which is a way to construct and deconstruct Scala ASTs. Uses the string interpolation mechanism as is with a bunch of clever macros to add the Q prefix to strings so that you can write Q and then some Scala code with holes in it. And you can actually match on them to kind of get, for example, the arguments out of a call that you're analyzing, or you can create some valid Scala AST. And the sky's the limit. You can do JSON or whatever. You can embed Java source code in those strings if you wanted to, because you can do triple quotes and have multi-line and so on. There are a lot. I mean, and I guess this is touching on why it's my favorite feature. It's actually really simple to implement this in a compiler. It's pretty simple to explain how it works, but there are a lot of things that people have done and that you would be able to do with it later. So the desugaring of the safe bottles version, that as you recall uses the format specifier here, that's what it desugars into. And that's because the f method here is actually a macro. I'm not going to go into how it works, but you can imagine what it does. It gets a constant for that string, and it looks at all the percent signs and figures out what the types need to be based on, D needs to be an int and so on. So that macro is standard, also a standard macro shipped with Scala 210. If you're very curious, I can test my internet connection and see if, yeah, there you go. So should probably. So this is in the Scala Tools Reflect package, and it does a bunch of analysis on how many parts there are. Does some parsing of the flags. It checks the types, and then it just looks at the format modifiers. And here, this is how we generate the trees. This is why macros are experimental. This is not the nicest API you can imagine, but these are Scala AST types or case classes that will generate the actual format call that you just saw. So that's how that works. So this is just this is the macro, and you can look at it for inspiration if you want to do something similar. But the point is that the actual string interpolation functionality in the compiler doesn't have to know anything about this. So since I said yes.
Suppose I want to do something myself. What I need to do I have to write a macro, or do I have
no.
to? So
well, it depends on what you want to do. So if you want to do compile time checking and say, well, hey, you wanted to splice in this, and the type of that thing doesn't correspond to what I was expecting based on analyzing the string constant that you supplied me, then that's something you would have to do at compile time. If it's just parsing JSON or something like that at runtime, then all you need is to enrich the string context class with a method that corresponds to the prefix you want to use. Any other questions? So this is kind of going all the way with this story, and now I've showed you how to construct data with string interpolation. I'll show you how to deconstruct data, which is what pattern matching is for. And the point is that once you understand how one of these directions of the equation works, you can understand the other one. It uses the same thing. So string, as I've not explicitly said, but string interpolation is a first-class concept. It's just a method call. It's just a value you can pass around. We'll apply this now to actually make this work. So I want to be able to use an interpolated string. I'm going to call it R for regex as a pattern instead of using it to actually create a value. So what this should do is say, OK, that's all it's doing. And I'm pretty sure it will run because the standard R should be in scope. If it isn't, it will. I'll come back to this. No. So it isn't standard. But we're going to implement it step by step. And we'll come back to this slide. And I promise you it'll work. So can this work? Because I kind of spoiled the question there. Yes, it'll work. So let's kind of work our way towards how would you figure this out on your own, right? Let's say someone gave this to you as a Scala puzzler and you bet $100 for it or whatever. How would you approach this? So the first thing I would do is get that weird looking pattern out of the way and put it in a value and kind of reason from there what you know about pattern matching and how it works. So I don't have to do this. It's just kind of a way to destructure the problem and reduce it to something simpler. I have to be completely honest with you. I kind of put them in gray here so you can't see, but I had to add parentheses that I'll explain later. That's a slight glitch. Nothing is perfect. So the idea is, though, that if we can make this work, if we can figure out the requirements based on doing the desugaring in full, we kind of work our way back and see what we need to do to make this work. So the extractor that we're going to use is going to be a special kind of unapply, which is unapply seek, which is one that can give you a variable length or a variable number of subpatterns by returning a seek instead of just elements for your tuple. So this is the first step in how you would desugar this according to the extractor pattern matching rules. So is this step clear? OK. So we've reduced the problem now to how do we actually give pattern an unapply seek method that will make this thing work. So the next thing here is I've desugared, as we already know how that works, I've desugared the string context, which is just drop the holes. There aren't any. So I just get one argument from my string context constructor. And R was the name I chose as my interpolator that I want to use. So that's going to be the method that we call. But there weren't any arguments. There weren't any subpatterns. You'll see that that is possible, too, in a minute. But that's what it is. So really what we've simplified it to is we need to add an R method to string context that when applied to this string will give something that has an unapplied seek that when applied to that will return a sum. That's what we want to achieve. So fortunately, that's pretty easy. And we'll use implicit classes, which are a new feature in 2.10. They're just a nicer way of writing implicit conversions from, in this case, string context to R context. So they give you a class definition that looks exactly like that with the implicit dropped and the corresponding implicit def that will take any string context and create an R context for you. And the real reason we're doing this, of course, is that we want string context to look like it has this R method. That's what implicit classes are for. They give you extension methods. So whatever appears in the single argument that we allow for a constructor of an implicit class, it will now look like something of this when it has to. When the compiler is looking for an R on a string context, it won't find it. As I showed you, it won't compile the slide as is. But as soon as we do this, it will. Any questions about that? So this is a new thing in 2.10, but it's not that new. It just kind of lets you drop the implicit def that you'd always write in companion with the class that you would write as a wrapper to add something to an existing class. OK, so if we run this, the interpreter that is running in the background will know about this now. And we can take this step, and I'm betting it'll work. So it has an exhaustivity warning, but the result is that it's OK. The exhaustivity warning is, well, you're only considering sum here. It might not match, right? The extractor that we wrote might actually say it doesn't. So this is a valid warning that we get, like with a lot of, we've written all this machinery from scratch ourselves, but you still get exhaustivity warnings. You could turn it off by just returning sum from the extractor, but we don't want to do that because in principle, these things may not always match. So this is another point where the same kind of behavior you expect with built-in case classes in Scala you get with your custom extractors. And that is part of my thesis that these things are simple. You don't get like some kind of newfangled string interpolation that just is often its little own universe, and you need to relearn everything that pertains to it. No, you just understand it how it works under the hood, which is pretty simple, and then everything else you already knew about Scala applies still. So of course, the desugaring, when I take it all the way, where we started, will work as well. So now we can kind of play around with this if you feel like it. do you have any suggestion of what we might do to this to break it, or to see if it really works all the way? I'm sorry? Yeah, let's do that. So I already put the cursor in the right spot. Should I just type it, or do you want to like have a stab at it, take a stab at it? Dollar something. Okay. And we'll just return something. Uh-oh. Why did that happen? Oh yeah, I didn't capture it. It's not creating groups, sorry. So it'll only work when it detects groups in the regex. This is something, if you wrote a macro, you could warn for this case where you try to capture something that hasn't actually been captured by the regex. It's not something I can do when you're only doing this at runtime. So let's get rid of this hideous stack trace and extract our 10, right? I forget whether I ran, I've set this talk up pretty carefully, so I was actually planning on using this as well. So you can take this all the way, and you can actually also inline convert this string to an int. So since these are subpatterns, you can write whatever subpattern you would write in your pattern matches. These are since you put your interpolated string in a pattern context, these aren't just variables. You can write arbitrary subpatterns. So what I've done there now is I've used the extractor that we defined earlier that will take a string and turn it into an int. And so now, before, I haven't run this one yet, I guess. But this one is gonna extract a 10 as an int. Right? And so that's where I'm, yes?
Disagree. That example.
OK. OK. Yes, true. Yeah. I agree. It's a bad example about as far as readability is concerned. I didn't really have the time to write a JSON example, for example, where I think it would make more sense to have holes and match on it. No, I don't disagree. But this is the simplest example I could think of to show you how you can write your own string interpolators and how it works across the board. Yes, there are a lot of things you can do in Scala. You shouldn't do all of them. That's kind of general advice about life. But yes, thank you. Absolutely.
Well, I mean, so the type of something is kind of determined by the macro.
So here, there are no macros at play here.
So how is there type checking for? There's no int declaration or something like that, right?
So the I is an unextractor. Here, I kind of glossed over it when I went back just now, but let me show it to you again. So I made this I thing that has an unapply method, which makes it into something that will take a string, look at it by doing it to int, and if that succeeds, it'll tell you, oh wait, that was the int that was in there in that string. That's the int version of the string. And so that's what I was doing here. So since I can write this, where this is in a pattern thing, sorry, in a pattern position would be slightly more accurate technical term. I can write this embedded in my interpolated strings as well. Does it make sense now? OK. So this is essentially the implementation vehicle for quasi-quotes, which have been merged into 11, the last milestone, where you write a bunch of clever extractors and macros to look at the ASTs inside those quoted strings. Yes?
The compiler executes code to figure out the type?
No, it just looks at the types. So it's sneakily hidden away in the I again. I probably should stop trying to fit everything on one line and just, as an example of bad Scala code, your public methods should have signatures. Don't let the compiler infer your types. Do as I say. No, it isn't. So yes, I mean, I would, in general, never write public methods without a return type, especially not if they're implicit. Don't ever write implicits without an explicit return type. It's gonna suck for technical reasons. So Yeah, so does that answer your question? So there's no like compile time magic. It's just the standard pattern matching type checking rules at play. The only change we had to do to the pattern matcher to accommodate string context was allow enrichment, or as we used to call it, pimping, of methods inside of a pattern context. Because before we didn't allow implicit conversion while type checking a pattern. Now we do, because otherwise you could never get the .r on the string context in a pattern context. But otherwise, the pattern matcher is none the wiser about string interpolation. OK, any other questions? Any other disagreement? OK, where was I? Yeah, so I just quickly wanted to mention that since we're talking about implicits, it's another kind of unification where type inference and value inference meet. So an implicit val is really just a value that's inferred rather than a type. Yep. There are a lot of cool stuff you can do with that. I would recommend not going too crazy with it. I once did, but I've seen the light since. Why is that come up again? Oh yeah, so I wanted to show you the one-liner that we just did, where actually patterns can also appear in variable declarations, not just in pattern matching constructs. So this actually does the same thing. It'll get the 10. It'll define a variable n and get that out. So this kind of brings me back to the beginning of the talk, where we're saying, like, SIP 18, where we take away some of the features from you. This is great stuff when you want to do really advanced things. I would not recommend doing this, as I'm sorry, I don't know your name, pointed out. But you can if you want to. So as I said already, quasi-quotes are a cool application, and the Kiyama team also is doing some cool stuff related to quasi-quoting. The desire for new toys is very high, and it has been high in the last couple slides. But we're a pragmatic bunch. I mean, I'm not going to tell our clients, hey, start writing a bunch of crazy string interpolators. I just wanted to show you guys how you can do it if you want to do something like that. We're really, we spent a lot of time thinking about Java interop, how to deal with legacy. But you want to balance that out with actually making it fun and without losing your sanity. So as an example of combos, immutable, yeah, let's stay on that bullet. But when you need it, it's there for you. And there's other features. I kind of anticipated your disagreement. I mean, there's other features you shouldn't be combining. Here, you write a var, and then you start doing stuff in futures with that var. You can do it. There's nothing we can technically do stuff to keep you from doing that, but we won't. We're just counting on your good judgment not to do that. So I mean, I'm just kind of glossing over the slide, but I'm just saying, like, shared mutable state in future is not a good idea. You can write this in Scala. I mean, you can write this in any language, right? And it's actually pretty easy to write this. You don't want to do that. And so that generalizes. And I think as a Scala community, that's really where we are. We're figuring out, now that we've kind of figured out all the stuff you can do, you need to figure out what you should be doing. And that's much harder. And I'm very grateful for people working on things like the style guides and giving talks about experience in companies and in bigger code bases. Those are the things that you should be paying attention to, not me, because I'm just going to show you my new toys. But there are a couple of cool things we're doing in this area with futures that, with for comprehensions and so on, they're pretty nice to write asynchronous code and do a bunch of arrest calls and not worry too much about the network and so on. But it's still a little tedious. So we've been working on Scala Async. Who's heard of Scala Async? OK, the rest of you, check it out. It's a really cool macro-based library for doing asynchronous computation. It's a lot like what the C# guys are doing, but nicer, of course. Where instead of writing that for comprehension and kind of writing your code monadic style, you just write a direct style. And under the hood, the macro will rewrite your direct style code into monadic code, do the transformations into ANF and so on. And all you have to do is say, this is a bunch of async stuff. Here's where I wait on my results. It's not blocking. It's just showing that you're coming out of the async monad. It's just saying, I need this result, instead of just composing futures, essentially. I don't really want to go too deeply into this, but if you're doing async stuff, check it out. We're getting very close to a first release there. I think it's very exciting. And then another example of macros being used under the hood. And again, I mean, I don't have anything against that as long as you're willing to keep up with the API changes, and we are because we're doing it. So another thing here is that the await thing is kind of like telling you the difference between future of t and t. And this is a nice thing, nice example where types actually help with I don't know, operational knowledge or something. Like it's important to know when something is a future of t and when it's a t for obvious reasons. I'm sure I don't need to explain that to you. So as I said, we're aware that there are a lot of bad parts. And I'm hoping, really, if someone wants to write Scala, the good parts, we're there to help you out and proofread or review. I don't really have time for that, but I think it would be a great book. In the meantime, we've been trying to give you some of the tools with SIP 18, where you can say, I don't want you to be able to define implicit conversions, or I don't want you to use postfix or higher kinds. Every time I see that, that hurts me, of course. But I implemented that a while ago. But hey, it's all good. If you don't want to use it, don't use it. And these things evolve. So this is our first stab at giving you a handle on the complexity that's there, admittedly. But it's complexity because there's just a lot of stuff. And it's complexity that's there for a good reason when it comes to certain problem domains. It's just not always something you would want to use. And so here's a quick overview. So for example, reflective calls is very useful when you write structural types. You might not know that you actually get reflective calls under the hood, because that's how we have to implement it on the JVM, for now anyway. You might want to not have to deal with existentials or higher kinds or dynamics or macros. So these are all things that become explicit in your code base where you're using them, except if you just do import language underscore, in which case you'll get everything. So one of those things you have to import is dynamic. It gives you a little bit of Ruby in Scala, I would say. And any class that extends dynamic will accept any method calls that you throw at it, basically. And we'll reroute them to message not understood if you message not understood if you're from Smalltalk. I don't know what it's called in any of those other real languages, but we call it apply dynamic. Because I don't know why, actually. It's just less scary name. So I'm not that inspired, and I don't think I'm going to. So, man, I have to import this or what? Think twice when you see this. So, OK, fine, let's import it. Uh-oh, sorry, got out of the editor. There you go. So obviously, the apply dynamic method got called when I wrote this method here that obviously isn't there in that class. It can be really nice when you're implementing DSLs or when you're dealing with data that's too dynamic to bother, or when you're experimenting with a REST API and some JSON data or whatever. I think there are a lot of cool applications for this. And you could use macros on top of that. Your apply dynamic method could be a macro that does actually check whether it's there or not if you're doing some kind of database access or something like that. Or you could write a type-safe dictionary where Paul hacked something together, where you just read in all the words, and you call some method, and it'll tell you, oh, it's in there, unsafely or safely. I'll just give you the link to the gist, because I don't think I have time to go into it. But this is how you could say, well, Bippy is not a word. Well, it kind of is now in Scala land, but it's not one. I'll wrap up in a second. Thank you. It's not, at least according to whatever dictionary you used. I don't remember which one. If you can write real fast, write down that number and check it out. Or ask me after. Or check my GitHub. Whatever you prefer. So quickly about Scala 2.11. We've been hard at work on a lot of just dealing with technical debt that we've accumulated over the last decade, and it kind of like depresses me every time I say decade. But so we've been working on modularizing the standard library, and the thing I'm most excited about is that we ripped out Scala XML. The compiler is the same way that string interpolation, for comprehensions, and so on are just a bunch of, they just translate for comprehensions or string interpolation into a bunch of method calls. It doesn't care what's underneath. Same thing with Scala XML. So you can plug in your own jar Scala XML is now a jar. If you don't load it, you can't use XML literals when you're compiling. But if you're not using XML libraries, you don't need it on your class path. If you do want to use XML literals and you happen to have some other jar, and you won't ask any questions where it came from, but it implements the same methods as the Scala XML jar, you can just use that. We're hoping to find some time to actually spec this, but we're kind of also waiting for you guys. We're kind of waiting it out to see if anybody's interested in doing that. But we're happy to work with you if you want to.
Is it with the deprecated or sneak it?
No, I mean, like, I think there's still too many people who are using it. It's more a way of, acknowledging the reality that not everybody wants to have to use this or have to have this on their class path, especially for resource constrained environments. And over the years, people have asked us about, how can I plug in my own XML library? So it'll be there. We're fixing bugs in it, but it'll be in its own GitHub repository, and it'll be pulled in just like any other module that'll come. So just a couple more slides left. So another theme in 2.11 is faster, and Greg, who's in here today, is working on an incremental compiler because that's really our main hope for giving you guys faster compile times. But we also have people who are working on the more long haul or long-term solution with a better optimizer and better cogen, EPFL, that's Miguel, and TypeSafe, that's James Irie. And of course, we're working on stabilizing these things. I was telling you to stay away from macros and reflection, and I think in 2.11, when it comes to using macros, I would recommend using so-called black box macros. Anything else, experimental. But we're working on maturing it. We really want to give you a nice reflection or macro API, but we won't call it official until we're comfortable with that. All right, thank you very much for your agreement, your disagreement. And I think we have a couple minutes for questions, but feel free to change rooms if you want to attend the next talk in a different room.